PC divided by 4. So what is the total transmitted power? It is a combination of carrier sideband powers. So substitute these values, we will get PT is equal to PC into 1 plus MA square by 2. So this is the important formula for finding the transmission power of any AM modulated waveform. Then we can relate the current relation with power. So the total power is PT. So if you are taking this PC into the left hand side, PT by PC is equal to 1 plus MA square by 2. So PT is equal to I square R in terms of current. So we can write PC as IC square by R. So we require PT square and PC square. So IT square into IC square is equal to 1 plus MA square divided by 2. So IT is equal to IC into root of 1 plus MA square by 2. So IT is nothing but the total modulated current, IC is the carrier current. And efficiency, how efficiently the AM modulated waveform is transmitted after modulation. So that is nothing but efficiency. So efficiency can be defined in terms of percentage. So percentage of efficiency is equal to power in the sideband divided by total power into 100. So sideband power is LSB and USB, total power is PT. So substitute those values. If you substitute these values in the efficiency formula, we will get MA square divided by 2 plus MA square into 100. So after simplification, we will get 33.3%. That means for critical modulation, the value of MA is considered as 1. How it is MA is equal to 1? Because for critical modulation, EM and EC both are going to be same. So we will get 1. So if we substitute 1 in the above formula, so we will get 1 divided by 2 plus 1, that is 1 by 3 into 100. So 1 by 3 into 100, which leads to 33.33%. That is only 1/3 of the total power is carried in the sidebands and the rest 2/3 are wasted while transmission. So we have to overcome this problem. So this is a modulation by a complex information signal. If the modulating signal contains more than one frequency, say two frequencies FM1 and FM2, the modulated wave will contain carrier and two set of side frequencies. So VAM of t is equal to sin 2 pi FCT. It is a carrier signal and the first set of sidebands. So 1 by 2 sin 2 pi FC minus F1 minus 1 by 2 sin 2 pi FC plus FM1 into T. So this is the first set of sidebands and this is your second set. The frequency is FM1 here it is FM2. So the coefficient of modulation or modulation index for this complex information can be written as MT is equal to square root of the sum of modulation index obtained from the different signals. So that is M1 square plus M2 square. Here we have considered only two frequencies. So M1 and M2. If you have n numbers, then you have to substitute that n number of values. In general, for n different signals, MT is equal to square root of M1 square plus M2 square to Mn square. So what is the carrier power? So the total power can be written as PC MC square by 4. So PT is equal to PC into 1 plus MT square by 2. Instead of total power, we have taken this total modulation index. Here we will have MA, but in case of complex information signal, the MA is replaced as MT. That is the only difference. So what are the advantages and applications of AM signal? So the major advantage is simple and inexpensive receiver. Easy to detect with simple equipment even if the signal is not a very strong signal. So it is applicable for very low frequency and for short distance communication. So narrow bandwidth than frequency modulation, wider coverage, well established mature art used for broadcasting almost exclusively. So these are all the advantages. What are the disadvantages? Received signal affected by electrical storms and other radio frequency interference happen. Receivers able to reproduce the frequencies up to 5 MHz or less than 5 MHz only. Insufficient use of transmitted power because only 33.33% of power is utilized for carrying your information, the remaining power is wasted. So these are all the advantages and disadvantages of AM. So your amplitude modulation is otherwise called as DSP-FC. What is DSP-FC? Double sideband with full carrier. So applications of DSP-FC are AM. Low quality form of modulation that is used for commercial broadcast, both audio and video signals. Two-way mobile radio communication such as citizen band radio, aircraft communication in very high frequency range. Then according to the sidebands, after modulation, the AM modulation can be classified into different ways. That is double sideband with full carrier, double sideband without carrier, single sideband with carrier, single sideband without carrier, vestigial sideband. Simply we can say that DSB FC, DSB SC, SSB with and without carrier, and VSB. So here double sideband with full carrier, we have one carrier, one USB and LSB. So the same double sideband, so we have two sidebands, but there is no carrier in this. SSB, only one sideband is going to be considered for transmission, either LSB or USB. Single sideband without carrier, so this is without carrier. Vestigial sideband, one of the sideband is going to be considered, and part of the remaining sideband is sent along for transmission. So that is nothing but vestigial sideband. Thank you.